Well, welcome back to Exploration Place. We are here in Design Build Fly, our award-winning gallery, and we've got some great things on tap today. This first one is probably going to keep your attention because it talks all about riveting. That's how our airlines are put together. When you're talking about putting metal together, one of the best ways to do it is with rivets. This is an actual rivet gun. We use this in our creator space to do occasional things, and it's pretty neat. This hammer goes in and out many times per second, and it's driven by air. It kind of sounds like a jackhammer would. You can think of it like a mini jackhammer, but then we would have a bucking block on the other side. You put the rivet through the two holes of the metal, and you beat them together until that rivet deforms to seal the two pieces of metal together. Now, we've got a trainer here in DBF. This is a giant wing, and this wing, you can actually see some of the rivets along the wing. If you look at those little round spots, those are actually rivets. And you would have had a person on the inside and a person on the outside riveting that to make it stay structurally sound. Now, to practice, we had to come up with a different way of showing how riveting works. And we couldn't really have somebody just sit inside the wing all day long. That wouldn't work at all. So what we did was we did an electronic version. So you'll see here, we've got a rivet and then a red light and a rivet and a red light and a rivet and so on and so forth down here. So I'm gonna try and time myself to do 1, 2, 3, 4, 5, 6, 7 rivets. How fast can I do these 7 rivets? I don't know. My record, we won't talk about my record because it wasn't that great. So first thing we're gonna do is notice the difference. Our rivet gun does not look quite the same. It's got a light sensor inside here. And what I'm gonna try and do is line it up with the light. I'll get a yellow, I'll pull the trigger, then I'll get a green, and I can go to the next one, okay? This is my timer right here. I'm gonna hit the button when I'm ready to start. Everybody at home ready? Here we go, 3, 2, 1. Not off to a great start, but I'm starting to pick up my rhythm. Oh, that one cheated me. Okay, I'm setting a bad pace for myself. Remember, quality over quantity. There we go. Okay, so I'm finished at 13.6 seconds. Not a horrible time, but you can see it already reset. So do you guys think I could do a little better? I feel like I could do a little better. I feel like I have a little more in my tank. That was my kind of warm up. So I'm gonna see if I can do a little better. Here we go. 3, 2, 1, go. Oh, come on. All right, we're almost there. There we go. 10 seconds flat. I increased bettered my time by about 3 seconds. I'm still not going to get hired by the aviation industry anytime soon. That was still not so great. But riveting is one of those things that we can do occasionally in our creator space, and it's one of the things that helps the aviation industry keep flying. Now, here is another section that we talk about. We talk about testing, and it's the one thing that students don't like to talk about. But in aviation, it makes a lot of sense. We have to test everything. And landing gear is one of those things that you really want to make sure works the first time, every time, because landing gear is what keeps you safe during landing. So we've got our wheel down here. This is an actual landing gear, and we've got it set up in a test structure. And in this test structure, what's going to happen is I'm going to crank the wheel. As I crank the wheel, the chain is going to pull the landing gear up in the air. It's going to get all the way up to the top, and then there's a button up there in the corner. When that button is depressed, the yellow light is going to go off, and it's going to flash, and then it's going to drop the landing gear from that height, and we're going to see it impact with the ground. Now, I will warn you, when I start to crank, when you see that yellow light start to flash, it's going to be kind of loud. So if you have your speakers on or your earbuds in, you might want to turn down the volume just a little bit so that that doesn't startle you too bad. We have people here in the building that on more than one occasion have dropped things because this is kind of loud and startling. So we're going to take this and start to crank it. We're going to crank it the other direction so that way it works better. All right, so we crank. You can see the landing gear is all set. I'm not quite to the button yet. I'm almost there. About 3 more cranks. I'm going to be there. Everybody ready? Okay, here it comes. Wow. And you can see that piston depressed down once it landed, taking on the weight of the landing gear. So we would have had a nice, safe landing. This is how the aviation industry, the FAA, all kinds of folks, this is how they test landing gears. And they'll test it to failure, and then they'll bring it back just a notch to make it safe for everyday flying. All right, next is one of my favorite parts here in the museum. This is our vertical wind tunnel. The vertical wind tunnel you see here basically has a big fan underneath it. Then it has, we'll talk about that in a minute. First, what do you do with a vertical wind tunnel? Well, we can build different flying vehicles. Excuse me, I get choked up kind of thinking about this, but we're going to build something like a helicopter. We're going to build something that spins. And as it spins, we're going to want to try and see if we can keep it stable, or we can build it to see if we can make it go out the top, or we can build it to see if we can keep it down low. So the way we do that is we actually grab some scissors here, and we're going to cut some slats in it. So as I cut these slats, I cut them on an angle. I'm cutting them on an angle for a reason. You'll see what that reason is here in just a minute. But these should all be at about the same angle. Now, when I fold these out, so I get little flaps, and these little flaps will act as my blades. Okay, last week we talked about propellers. Well, think about blades on a helicopter as being propellers that are sideways, and they help lift the helicopter up. So that's one. Let's build another one with a little bit different idea. There's also a spiral that you can cut. Let's see if I can do this one. This one is not my specialty. We have some guests that I've seen build some amazing spirals, kind of like peeling a potato. So we'll see what that looks like when we get in there. And then we'll do one more that has nothing done to it to see. This will be our control. So we've got all three of these ready to go. We're going to come right over here to our vertical wind tunnel. All right, now inside the vertical wind tunnel, if you look down here, as you visit, you may have noticed that it looks like there's a bunch of drinking straws. These are actually a honeycomb section that's put on top of the fan, and it's to give us a laminar airflow. And a laminar airflow means that the air is going in straight lines. The fan at your house sends air out, and it's usually twisting and turning and all kinds of turbulence. And that doesn't work very well for this type of an application. You want to have nice, still air going in one direction. Last week when we looked at the wind tunnel, you saw the smoke going across and it was nice and smooth until we put something into it. Well, this is going to be exactly the same. We've just turned it on its side, going straight up in the air. So you may have seen something like this when people skydive indoors. They can get in those big suits and fly. So it's similar to that. So the first thing we're going to do is our control, and we're going to see what happens. So I'm going to turn it on, and this is an electrical switch, so I'm just going to hit it once. It turns the fan on, and now I'm going to listen for it to get up to speed. It's getting there. It's getting there. It's there. All right, here we go. So I'm going to throw this in. Ready? Go. Very, very underwhelming. Did not do a whole lot. We'll try that one more time. Ooh, that one, it kind of just stood there for a second, but it just doesn't really want to do anything because it doesn't have anything to grab the air. The air just goes right over the top of it. It's very aerodynamic. And some people might say, well, why don't you put it in this way? Because it'll flip right over, because gravity still works and it wants to pull the heavy end down. So now we're going to try my curlicue pig's tail. Let's see what happens there. Whoa. Kind of the same thing. Not a whole lot to grab the air with. Nope, not going to do it. So now let's hope my last try, my blades, will work. Woo! Okay, well, let's make a slight deviation. We're going to tilt our blades down just a little bit. This is one of the reasons I cut it at an angle, was to allow me to fold over the tips like so. Now I'll throw it in, and we get spinning action. And it's staying right here at head level, going back down, dipping down, going back, going up. Not too bad. Oh, it's got a nice spin to it though. You notice how the spin started after I folded those fins over just a little bit. It actually starts to spin and dance. Not a great build on my part, but you can see the spin. Anyway, this has been our vertical wind tunnel. We've talked about riveting, we've talked about our landing gear. We can't wait to see you guys back here at Exploration Place when we can reopen. But until then, stay home and stay safe, and we'll see you next time.